Resultant vector distance problem. Problem: an airplane flies north 20 degrees east for 200 miles and then changes direction and flies south 42 degrees east for 500 miles. Find the resultant vector. So when you find the resultant vector, we're going to want magnitude and direction. Solution: make a sketch of the vectors and solve. So we made a sketch. We start in the bottom left-hand coordinates where the 20 is, and so we start there. We go north 20 degrees east, and then we go out that line 200 miles. Then when we're at that point, we have a new vector coordinates, so we're going to go south 42 degrees east, and we're going to go out that arrow 500 miles. Now the thing we could have done is to go out the D distance, that distance, and in that direction, and that would be the resultant vector. The vector that would do the same thing as those other two vectors. Step 1. Using the law of cosines, we're going to find D, because we do know the angle by finding the alternate interior angles, the 20 and the 20, and the 42. That makes that a 62 degree angle up there. So we can find side D. So we apply the law of cosines by using D squared equals 200 squared plus 500 squared minus 2 times 200 times 500 times the cosine of 62. And we get D squared is equal to 196,105.68. And taking the square root of that, we get 442.8 miles. So D would be 442.8 miles flying from our original point in the direction that D is going. So we found the magnitude. Now we need to find the direction. Step 2. We can find the direction by finding the angle theta. So let's see what we could do there. The sine of theta over 500 is equal to the sine of 62 over 442.8. Now the only bad thing about this is we're using the side we found earlier in step 1. So if that one's right, then we'll be okay, but if we made a mistake there, it'll carry through to this. So now we solve this for sine theta by multiplying both sides by 500 and then evaluating, and we get 0.997. Then taking the inverse sine of 0.997, we get the theta is 85.6 degrees. Now that's the big angle theta in the triangle. So step 3, x equals 180 degrees minus 20 minus 85.6, and that'll give us 74.4 degrees. And that's that angle below D going down to the southernmost arrow. So step 4, the resultant vector has a magnitude of 442.8 miles at south 74.4 degrees east. So that's where we got the final resultant vector that would do the same thing as if we flew in those other directions for those distances.